Let's continue on our psychogeometry. We have Theorem 5, opposite angle of a cyclic quadrilateral are supplementary. What it means that x plus y is equals to 180. Supplementary angles are angles that sum up to give you 180. And so how do we prove this to arrive at 180? Supplementary angle, let's try to join this to prove this. From our previous theorem, you will agree with me that angle at center is 2 times angle at circumference. So if you mark this one, this place will be what? 2x. Also, looking from the other way around, this angle will also be 2 times what? Angle at circumference, which is y. Then you have your 2y. Angle at center is 2 times angle at circumference, and that is how we arrive at this 2y and 2s. Okay, so what we do from here now is angle at a point, they meet at a point. So you can now say that 2x plus 2y is equals to 360 degree, angle at a point, some angle at a point, okay? Some angle at a point. And therefore, what do we do next? We factorize. 2 into here, we have 2x plus 2y is equals to 360. And so divide both sides by 2 to clear the coefficients of x plus y. You will now have your x plus y all equals to 360 degree divided by 2. Automatically, you will have the value of your x plus y to be 180 degree. So that is it. It is proving that opposite angle of a cyclic, some angle that is opposite angle of a cyclic quadrilateral are supplementary. When you add them together, you have 180. So that is all about. So let's look at another rule, Theorem 6, which I call Theorem 6. Okay, it might not follow serially as it is in your text, but just follow me on this. That external angle of a cyclic quadrilateral is equal to opposite interior angle. This is another theorem. Exterior angle of a cyclic quadrilateral is equal to opposite exterior. So this angle are equal. So let's draw and let me show you how it looks like. Let's draw it and I will show you how it looks like. Let's have a cyclic quadrilateral. Let me have it this way. And we have something like this. You have your angle to be here, which is x1 is equals to x2. This is opposite external angle of a cyclic quadrilateral is equals to opposite interior. This is opposite to this. Okay? That means x1 is equals to x2. How do we prove this? Let's call here y. Okay? From there, we can now see that x1 plus y is equals to 180. The above rules we just proven that opposite angle of a cyclic quadrilateral are supplementary. Opposite angle of a cyclic quadrilateral are supplementary. a supplementary angle. Also, we have x2 plus y is equals to 180 degree. Some angle on a straight line. Some angle on a straight line. Okay? Some angle on a straight line. Are you following? Therefore, if this x1 plus y is equals to 180, x2 plus y is equals to 180. Therefore, x1 is equals to x2. And that is what we are saying, that external angle of a cyclic quadrilateral is equals to opposite interior. And that solves the theorem 6 proving. So let's look at some of the example we have and see how we can apply the rules. From here, you can see that we are given angle at the center, and to find x, find the value of what? X. So you will extend it on your own. You can use so many of the rule. You extend it so that you apply angle at center is 2 times angle at circumference. You can call here anything. You can call it small a. Okay? So from here, 2a is equals to 126. That is, angle at center is 2 times angle at circumference. Angle at center is equals to 2 times angle at circumference. You go back to the previous video, you will see the theorem, and it's well explained then. So what is the value of our a here? A is equals to 126 degree divided by 2, which will give us 63 degree. That is the value of our a. But that is not what we are looking for. We are looking for the value of x. From here, we can now apply opposite angle of a cyclic quadrilateral as supplementary. We now have our x plus a to be 180. Opposite angle of a cyclic quadrilateral as supplementary. Okay, supplementary. So we now have x is equals to 180 minus a. Our x is equals to 180 minus 63. 63 degree. X is equals to 117 degree. So that is the value of our x. So that is that. It's as simple as ABCD. You can solve it anywhere. Take it to your room, take it to your class, take it to your village. You will still have the same answer. So from here now, the last rule will prove that interior angle of a cyclic quadrilateral is equals to opposite exterior. See, this is the theorem we've just proven, that x1 is equals to what? X2. So when you look at this, no matter how the diagram is being turned to, you still follow the same process, that interior is equals to opposite exterior. So this angle is equals to this angle, which is 2. And therefore, we cannot have a triangle attached to it. So what we do is to find y, which is y plus 102 degree plus 47 degree equals to 180. What is your reason? Some angle in a triangle. Some angle in a triangle. Some angle in a triangle. Okay? And therefore, you have your y plus 149 equals 180 degree. Your y is equals to 180 degree minus 149. Okay, so what is the value of your y? The value of your y, if you take 180 from this, you have 31. Okay, 31 degree. So that is the value of your y. So what you do is to go over the rule, the theorem one by one. In this tutorial, I've stated from 1 to 6, but it might not follow like that in your textbook. But when you follow and know specifically what each of the theorem is all about, you will be able to get it and apply it correctly. Make sure you can state all the theorem 1 to 6 offhand and draw a diagram that can suit your explanation. It's then that you'll be able to apply it very well. So see you in my next video, We shall come up with more examples on this. Bye for now.